Hey everybody, we're now in module 3.4 and we're talking about exponents. In this module, you're going to learn about a new rule of exponents that you've probably not heard before. When I teach new rules related to algebra, the first thing I like to do is back it up and look at arithmetic. So if you look at my expression 3 squared times 3 to the 4th, if I asked you to work that out on paper and not use a calculator, let's talk through that approach. Well, we would take the first term, 3 squared, and we know 3 squared can be written as 3 times 3. So we would write that base 3 twice. Then we would have the expression 3 to the 4th, and we know that term means write the base 4 times. So 3 to the 4th means 3 times 3 times 3 times 3. So now on your paper you have 3 times 3 times 3 times 3 times 3 times 3. Which if you really look at that, how many 3's do you have written that are connected by multiplication? Well, if you start counting them, you have 1, 2, 3, 4, 5, 6 3's. And instead of writing 3 times 3 times 3 times 3 times 3 times 3 out the long way, we could rewrite that as 3 to the 6th power. Because that's what that expression means. It means I have that base 3 6 times. Now, my job is to show you how you can do 3 squared times 3 to the 4th without having to do that middleman, that paperwork. And if you look, you know your answer is going to be 3 to the 6th. So if you look, 3 squared and 3 to the 4th both have in common base 3. What we did with their exponents 2 and 4 is we did not multiply them. If you have an exponent of 2 and an exponent of 4, to make an exponent of 6, you did what operation? That is correct, you did addition. So the rule in algebra is going to be when we multiply the same base, we don't do anything with the base. The base stays the same. What we're technically doing is adding those exponents, because those exponents are telling you how many of the base I have, how many of the base I have. And if I put it all together, I'm adding how many of the bases we have total. So you will hear me say throughout this course, multiplying variables means to add exponents. Because when we multiply letters, variables, the letters are going to be the same. All we're going to do is add the exponents. So look at my next example in our PowerPoint slide. I have x squared times x cubed. Now I want you to pay close attention. We are not adding, we are multiplying. If I asked you to add x squared to x, you couldn't add those because they're not alike. So here's where the confusion begins. To understand algebra, you got to understand the rules of arithmetic. And we've already discussed, to add and subtract, you have to have like terms. And in algebra, an x squared is not like an x because they don't mean the same thing. X squared could stand for xylophones, and x can stand for x-ray machine. But we're not doing adding and subtracting now. What operation are we doing? We're doing multiplication. And you can multiply terms that are not alike. Now you're going to say, how is that true? How in real life do we not multiply things that are not alike? I'll give you the perfect example. My example is going to be with dogs. I just happen to like dogs. Let's think about this. If I had a poodle and you had a poodle, and I asked us to add them, could we add them? Sure. One poodle and one poodle would make 2 poodles. And we could add because the poodles are alike. If I had a poodle and you had a Labrador retriever, could we add that? No, because they're not alike. We would have to say 1 poodle plus 1 Labrador retriever. However, now let's take that in the context of multiplication. Multiplication of animals is breeding. That's your direct correlation. When you breed animals, you're multiplying. You've all heard the phrase, multiply like rabbits. Okay? So let's think about this. If you had a poodle and I had a Labrador retriever and we breeded them, we multiplied them, they would make a puppy, which is called a Labradoodle. which is totally different than a poodle and totally different from a Labrador Retriever. So guys, you can multiply different animals, different breeds, and get a new breed, a new result. If that's true in the real world, then that's true in algebra. We can multiply different terms that are not alike and get a new term that's different. So I want you to understand, we can multiply x squared times x. They're not alike. They don't mean the same thing. That's an xylophone and x-ray machine, but we can multiply it. And the rule is to multiply variables, you add the exponents. Now the part that's the same is that base part. The x's are all the same. So if I take x squared and multiply to x and multiply to x cubed, even though the three terms are not alike, an x squared is not like an x, and it's not like an x cubed. So those stand for three different ideas. That's an xylophone, an x-ray machine, and extra special something. Even though we can't add them or subtract them, we can multiply them. And the rule is, as long as all the bases, the bottoms, which are the letter x's, are alike, all we do is add the exponents. So on x squared, what is the exponent? It's a 2. On x, what's understood to be the exponent? Very good, it's a 1. On x cubed, what is the exponent? It's a 3. So what that's saying is if we add 2 and 1 and 3, we would get the number 6. So x squared times x cubed is x to the 6th. If I did it the long way, I'll show you it means the same thing. X squared means there's 2 x's. X means there's another x. And x cubed means there's 3 more x's. So if you write 2 x's plus 1 x plus 3 x's, how many x's do you have altogether? You have 6. So the rule of thumb that we got to get through our mind is, if we're multiplying variables, what do? We do nothing with the variable. The letter x stays x. What we're doing is we're adding the exponents. And our product, our answer, is totally new and unique. It's something different. And x to the 6th is not like an x squared. It's not like an x. It's not like an x cubed. So what we're doing in real essence is we're breeding. We're taking two different terms, multiplying them together, making our new product, which is different. We're going to try this in the next video. We're going to do some hands-on. See you then.